Okay, so the last kind of little bit in logs and exponentials is to do with graphs with logarithmic axes. Okay, and the reason that we use these is because sometimes it's to do with interpreting experimental data. You've done an experiment, you've been looking at a reaction or something that's been happening, and your data shows an exponential growth or an exponential decay. And doing any analysis on that graph can be really difficult because the graph goes really, really high really quickly. So it could be that at 2 hours your value is up in the millions or something kind of ridiculous, but you want to be able to quite easily kind of show and analyze your data. And to do this, you can do the logarithm of each axis, and you can do this when you've kind of got two forms. So you kind of have y equals kx to the n, and that's when you've got two logged axes, or axes, two log axes, and you've got another one which is y equals ab to the power of x, and for those you have one log axis. Okay, so the first example we're going to do is this one here, where we have log to the base 10 of x on one axis, and we've got log to the base 10 of y on the other axis. And we've been asked to do what is the relationship of this graph in the form y equals kx to the n. Okay, so kind of the first place to start is with our y equals kx to the n. Okay, we have a straight line, so we're aiming for something that's going to be like our straight line equation. So we're kind of aiming for something that's a little bit like y equals mx plus c. Okay, and when we do that, that is going to help us quite a lot. So we can rearrange this equation. If we take the log to the base 10 of both sides, so we can get log to the base 10 of y is equal to log to the base 10 of kx to the power of n. Okay, so we're kind of getting there. We've got our log to the base y instead of our y, which is what we have on our axis. We don't have y, we've got log to the base 10 of y. So that side we're sorted. So we need to do something to this other side to get it of a similar way that we need it. So we can split up our logs. So we get log to the base 10 of k plus log to the base 10 of x to the power of n. And so we get log to the base 10 of y. When we kind of higgledy-piggledy move it about a bit, I'm going to move this kind of one over here and take the n down the front, so we get n log to the base 10 of x plus log to the base 10 of k. And you can see here our y, this is our y in there, and then we've got our log to the base 10 of x is our x, and this is our c. So for our kind of straight line that we've got, which we've got in our graph, we know that our n is going to be, in fact, our gradient, and our log to the base 10 of k is, in fact, our y-intercept. So from there we know, so our y-intercept, so it crosses that x-axis, so we've got log to the, or the log to the base 10 of y-axis in this case, so we get log to the base 10 of k is equal to 0.3. So we can rearrange this. Our 10 is our base, so it becomes the base of our exponent. So 10 to the power of 0.3 is equal to k. And that's just rearranging our logarithm. Okay. And from there we can get that k is in fact kind of roughly equal to 2. Once we've rounded, we'll get kind of close to 2. Okay, and then from here, our gradient, that's what we need to find our m, or our n. So our n is equal to our gradient, which is our y2 minus y1 over x2 minus x1. It might have been a while since you've seen it, but you can't forget about the gradient formula. everything that you needed to know at National 5, you still need to know now. So we've got 0, 0.3, and our other point is going to be 2, 8.3. So we are going to have 8.3 take away 0.3 over 2 take away 0. So we're going to have 8 over 2, which is 4. So therefore, we're going to have y is equal to 2x to the power of 4, and that's what that logarithmic graph represents. Okay, that's for where we have a log on both axes, but normally in these they will actually tell you what form to put it into, so don't worry too much about that. If you see one of these questions, they'll tend to give you that. Right. Okay, so for our second graph, this time we have right in the form y equals ab to the x, and we have a graph here where we've got our x-axis still an x-axis, and our y-axis has become log to the base 10 of y. Okay, so the place to start is still the same. We start with our y equals ab to the x, we take that down, and we need log to the base 10 of y, so we're going to take the logs of both sides. So we get log to the base 10 of y on this side equals log to the base 10 of ab to the x. We can then, from there, split our right hand side, so we're going to get log to the base 10 of a plus log to the base b of x, and that's equal to log to the base 10 of y. Okay, so again, a little bit of rearranging. Log to the base 10 of y is equal to x times log to the base 10 of b. I missed out that 10 there, but it's not technically necessary because remember from previous ones, if you just have log without any base written next to it, it is log to the base 10. And then we've got to add log to the base 10 of a. So in this case, we're still kind of going from our y equals mx plus c kind of perspective. So this case, it's a little bit more complicated. And you can see that our y is still there, our x is the same, but this time it's our log to the base 10 of b that's going to be our gradient, and our log to the base 10 of a is our y-intercept. Okay, so we can go from there, and we're going to get, going from our gradient first, we're going to find the gradient using the formula y2 minus y1 over x2 minus x1. Okay, so that's going to give us, with our points, we have 0, 1.3, and we've got 3, 0.1. Okay, so we're going to have, on the top, we're going to have 1.3 minus 0.1, and on the bottom, we're going to have 0 minus 3. It doesn't matter if you've got them the wrong other way around, you're still going to get the same kind of thing, and you're going to get, once you've kind of plugged that into a calculator or worked it out, you'll get negative 0.4. Because we're going to get 1.2 divided by 3, which is negative 0.4, and then from there we know that's our gradient m, and so we need to find our b. So we've got log to the base 10 of b, which we now know is equal to negative 0.4. Okay, so the base of our logarithm becomes the base of our exponent, and we get b is equal to 10 to the power of negative 0.4, and that actually gives us that b is equal to 0.398, and then the decimal keeps going, and so we can round that to roughly 0.4. And from there we also know our c value is equal to log to the base 10 of a, and our c is our y-intercept, so that's just where it crosses graphs. So we get 1.3 is equal to log to the base 10 of a, and again the base of our logarithm becomes the base of our exponent, so that's where the 10 goes, the 1.3, and we're getting our a. So we're going to get that a is equal to And that, again, we get a decimal 19.952, which is roughly equal to 20 if we round it. Okay, so then we can write our formula. So therefore, y is equal to 20 times 0.4 to the power of x. And you can kind of write that 0.4 to the x in a bracket if you so wish. Okay, so that's the end of the logarithms and exponentials. If you've got any questions, feel free to ask in the comments, or if you happen to be in my class, you can ask in class, of course. Okay, logarithms and exponentials all done. Thank you for watching.